How to compile a blinking code made for microcontroller PIC16F877A using the MPLAB and Proteus. First, we will begin with compiling the code and generating the .hex file on MPLAB. So we will make a new project, file, new project. Then we'll choose microchip embedded standalone project because we will make a project from scratch, and then next. And here on the family we will choose the family for the PIC16, which is the mid-range 8-bit microcontrollers. Then here on the device we will write PIC16F877A, which is the device that we are using. Here on the tool, if you will using the simulator of the Proteus, so you will leave it here like no tool. And if you will connect your laptop with a burner, and you will burn your code on a big chip. So here you will connect the programmer, and if you connected the programmer, you will open this window and you will so here in this combo the programmer. So for us in this video we will not use the programmer, so we will leave it like this, no tool. Then next, here we will choose our compiler, which is the XC8 compiler. Then next, here we will write our project name. I will choose blink underscore code. We can use blink11. Then here we will browse to save our project in a location that we know, because when we will come to the step of burning the code on Proteus, you have to know the exact path of your .hex file so you can import it. So here I will check the location. Maybe I will choose Mac Pro, then documents, and here I will create my project. I can create like a folder here, documents, and then in documents I will create my project here, then finish. As you see in project folder, the folder for the project it will be created automatically for us, and then finish. The project is set up. Now here's the project, and we have some files and libraries, and if you want to check that you made the previous steps well, so you will see here, this is a project, this is the device that we are working on, which is the PIC16F877A, and all of the stuff, the compiler and so on. Now we want to make a main.c file so we can put our code and compile it. So here we will select the source files and right click, new main.c, then finish. Here is the main.c file. I am having the code, I wrote it before, so I will paste it here. If we check the code, we will see that our line define the working frequency of our crystal oscillator connected to the PIC microcontroller. We choose the 4 MHz crystal, and here we included the header file for the compiler, so we can use the ports, the registers, and the delay functions all on the compiler, and we don't need to make any declarations. Then we will choose our code, which is the int main, and first we will choose the port that we are working on. We choose the port B, and we will use the first band for port B, which is band 0. So this bin, as we know that in the big microcontroller all the ports are bidirectional, so we have to determine the direction, is it input or output. So in the big microcontroller we have like a trace register for each port. We have to set the direction of the port on. So we will use RB0, which is the first bit on trace B, so on port B, so trace B0 is the bit that we want to write it to define the direction as a 0. As a 0, it determines its output, and if we want to make the direction input, we will put here a 1. So here we define the direction, and in this line we turned on RB0, so we write it RB0 equal 1, and then we set a delay. It's like 1 second, which is 1000 milliseconds, so we use the delay ms stands for millisecond function, and then RB0 equals 0, so we turned off the LED and another delay, and then we put this code on a while one loop, so that this code will be executed forever. Now, before compiling our code, we need to add the configuration bits. So we will go here for this tab, which is window, then select here target memory views, and then we'll open configuration bits. Here in the configuration bits, the first thing we will choose is the frequency oscillator. Is it hardware or something like this? So we will choose HS. HS means a hardware oscillator, which is from outside. And here the watchdog timer, we will make it off, so it will make the operation simpler for us. And then the LVP bit, we will make it as off, so it will be using as a digital I/O. So here, if you check this, you will see RB3 is digital I/O, so now you can use all port B as digital I/Os. Now we want to generate our options as a code, so we will click generate source code to output, and then take these lines of code, copy it, and put it here before the int main. Now our code is ready to be compiled, so we will click here build. So if this message pops up, that means our code is successfully built, compiled, and our .hex file is ready for us to be burned on the Proteus. Now we can go for Proteus, choose file, new project, then here we can write our project. We will call it Blink11, then next, 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 and finish. Here in Proteus we have several modes, and this depend on what we want to put in this schematic sheet. So now we are in the selection mode. We want to go to the component mode to select our components. So click here and then click this P, and here we will choose our microcontroller, which is 16 with PIC16F877A. Here it is, and then OK. Put here the microcontroller. Then if we want to turn on and off the LED, we want to bring a LED, and we can't connect the LED directly for the microcontroller, so we want to put like a resistor for protection before the LED, and then we'll connect it to the ground. So here we will go for the components again and write here 120 ohm resistor, and check these options until you see a resistor. So here you will find here res 120 ohm, and then okay, so we will put it here. Then we will go back to choose our LED. We can write LED green. Here it is. Okay, we want to rotate it, so we will click on it and then rotate anti-clockwise. Perfect, this is the one. And now we want to put here a ground, so we will go to this options and choose the terminals mode, then choose ground, and here we put the ground. Now this time we want to connect our components, so RB0, this is our bin, and here and here and here, then they are connected perfectly. So we will connect, so we will choose selection mode, and we will double click, then we want to choose the file. So we will go for, we put our file in documents, and here is our folder for the project, and here and here and here. No, the X file is not here, so I think it's here. Here it is. Okay, so blink11.x.production.hex, then open, then okay, and go to choose debug, run simulation. Oh, here's the LED is turned on and off, and now on and off forever, because we are using the while one loop. That's it, and thank you.